So let's talk about how to do a regression in JASP. And I do want you to remember that correlation and regression are very much linked. And so if you haven't run a correlation already on your data set, you should start with that. So the first thing we want to do is make sure our data are set up appropriately. So these should be indicated as numbers. The way we know they're numbers is that this little ruler icon. If for some reason it's noted as something else like nominal, then you'll click on that picture and change it to scale. If these are not set up as numbers, you will not be able to do the appropriate analyses. So first we're going to start with our correlation. So I'm going to click on regression and run a correlation matrix. Now we want to correlate these two data, but here's a tip that I didn't indicate to you before. If you put your X variable in first and then your Y variable. Now remember, it does take some mental effort for you to figure out which one's the predictor and which one is the predicted. But we're trying to use study hours to predict test score. Now our correlation matrix, it doesn't matter because it's going to be a paired comparison. It doesn't matter which one goes first or second. We can see that there's a correlation of 0.707, and it is significant because this p-value is less than 0.05. But if you scroll down here to plots and I click correlation matrix, what's nice is it plots the scatter plot for you and the rough line that we will be needing for the regression equation. So that's super neat because it allows you to visualize what we're looking at here. We can see that the y-intercept is going to fall somewhere in here, and we can see that it's a positive slope. So that's visuals are always really good for us to start with. So now that we've have the correlation, now let's run the regression. So I'm going to click on regression again, and now I'm going to click on linear regression because remember, we're doing straight lines in this class. And here it asks you to identify which one is the dependent variable and an independent variable, or the predicted and the predictor. So the predicted variable, our outcome variable, is test score. So that's our dependence. Remember, you might want to put in your notes that your Y variable is the one that's marked dependent variable. And then study hours goes into the covariate option here. And so I'm going to click OK. And then let's talk about all of the data that we have given to us, because there's quite a bit of information going on here. So first I'd like you to see that, notice that this was the correlation we got before, 0.707. I don't want you to think, though, that this will always be your correlation. This is the model for multiple variables, because sometimes people use study hours, IQ, and how much you like stats, all those things to predict your test score. So this model would include all of those variables. Some of those variables will be positively related to test score, and some of them may be negatively related, like say stress. More stress would be less of a test score. So this model collapses across all positive and negative and just tells you the overall correlation. So this number here will always be positive. So even if you have a negative correlation in your model, when you run it, this will look positive. So I don't want you to misleadingly think that this is your correlation. It should be the same number, because in this class we're only going to be doing paired comparisons. We're not going to be doing more complex multiple regression. But because this is running a model, it'll always make it positive. Now, remember, I will ask you for the coefficient of determination, and guess what? They did the math for you, which is super cool. So the coefficient of determination is represented here, so we could use that later on when we need it. And so then we have a lot of stuff, but really what you need to pull out from this picture is, or from this result, are these two things. So what we really need to develop our equation of the line is the y-intercept and the slope. This unstandardized column here is where we will get the answers for our y-intercept and our slope. So of these two, which one do you think is the y-intercept? So hopefully you're thinking intercept. So this is our y-intercept for our equation of the line, and then our slope is 2.445. Now, this wording here for slope will change. It depends on whatever we've labeled our x variable. So if I were using stress here, it would say stress. So the intercept word will always say intercept. So the y-intercept will always be labeled intercept, but your slope will always be labeled whatever your x variable is. So if I were to write this equation out in the y equals bx plus a format, it would be y hat equals 2.445x plus 23.074. I just want to go back to this picture here and see how you can kind of see that happening. See how we saw the line kind of come down somewhere near 20? That means the y-intercept is somewhere around 20, and then when we actually had to do the math, it was 23 something. And then we see it's a positive slope. Oh, you could probably eyeball it, but it says it's about 2 something. So our equation of the line is going to be y hat equals 2.445x plus 23.074. So that's what we needed to do to get that equation in JASP. And there's one last piece I'd like to pull out before we move on to seeing how this all looks in a full-fledged example. But see where it says Rmse? This stands for root mean squared error. This is our standard error of prediction. So JASP has done that math for you. So the standard error of prediction is how wrong we are in using the equation of the line to predict a new value, a new predicted value of y given an x value. So if you give me an x, I'll predict your y, and I'll tend to be wrong about 20 percentage points, or about 19 percentage points of the predicted test score. So root mean squared error is the standard error of prediction. So now in my next video, we're going to run through several questions we could ask with correlation regression. We'll pull out all the things we needed from this report to answer those questions.